Okay, we're going to use the Meet Echo slide sharing tool. So chairs, which means yours truly is going to be advancing slides. I will try to listen carefully for next slide and other cues. I think that's our cue to get started, Gory.
Indeed. Well, this is the last session of this current IETF plenary meeting. The TSVWG is meeting in this session. And I'm Gory Fairhurst. I'm one of the co-chairs here. David, can you introduce yourself?
I'm David Black, another co-chair, other side of the Atlantic from Gory.
And Wes.
And I'm Wes Eddy, and I'm on the same side of the Atlantic as David.
Okay, so in this second session, next slide, please. We are going to cover a set of drafts on transport topics. If you haven't read the note, well, at this point in the IETF, it's a good time to go and read it. Otherwise, I expect you're familiar with this slide from other talks this week. Next slide. Here's our agenda for session 2. We're going to keep the agenda review very short. Within it, we're going to invite Michael to give a brief update of what happened in RFC 4960 BIS as it passed working group last call and is now waiting on the IESG tele chat. Then we will look at 2 SCTP drafts, followed by 2 drafts relating to UDP options, a DCCP draft, and finally some discussion of the DiffServ specs. This more or less fills our time, but as ever, we're interested in receiving questions and feedback at the mic. So if you have questions, please come and ask.
Yeah.
But please keep your questions short so that we can move on. David.
Yeah. One note for the AD: holding TSVWG down to 2 hours this meeting week did not work. We needed at least 3 to 4, and so everybody gets squeezed. Also, for the sharp-eyed reader who's paying attention, there's an IETF token missing from the name of the very last draft in this slide. We're hoping people can figure out where to fill that. It's draft IETF TSVWG DSCP considerations. Okay.
Here's the organization. Yeah, here's the organization. We have a note taker. Thank you ever so much. We have just 1 hour. We expect an interim to come in the next IETF period. So please help the chairs prepare for that interim and look out for it when it's announced. And we will discuss support for starting an adoption call of this. We've already done this.
This is an old slide that needs to be updated.
RFC 4960 BIS is on the telechat. Nuts up, passed working group last call, then received some external review as we invited an external reviewer to look at it. It received review comments. These were late. They were substantial in that they were talking about possible other use cases. It was discussed at the interim, and it's currently back with the working group for a new revision. So we'll talk about that document here. Hopefully we'll turn it around the working group for a short period of time, and then we'll resubmit that to the IESG for publication. That would be our plan. Next slide.
We'd be done here, so let's see if we can get a...
This is Michael Tuxon's slide on this. Go ahead, Michael.
Yeah, this is about RFC 4960 BIS. Next slide. These are the earlier versions. Next slide. this is what happened between the last IETF and this one. We had 3 revisions, basically cleaning up things, and revision 15 went into last call. And we got, we have the directorate reviews and we have AD reviews, and some of them were in the form, the protocol could change in a substantial way, which were rejected, and some other changes which were incorporated. Next slide. So the changes which have been incorporated is it has been clarified how to handle the case when an advertised receiver window is smaller than 1500, which is required. There was a discussion with the security people on the cookie. So it's made explicit that the content of the state cookie is implementation dependent, that the cookie is not encrypted, or at least that the specification does not require it to be encrypted, and that the key used to sign this stuff should be changed frequently, and frequently is specified as hourly, for example. The limits for outstanding TSNs and SSNs we're using should not, and that is has been changed to must not. And one other change was that during slow start, the congestion window was only increased if the cum-ag point has been moved forward. This was changed in earlier versions of the specification. This applied to slow start and congestion avoidance. This was changed for congestion avoidance, but not for slow start. This is now also changed for slow start. And the IANA section has been updated, and it was missing a policy for the PPIDs. All the other changes are improving wording. The document, I think, is on the telechat from mid-December, and I'm expecting some more comments during the time the ADs read it.
So thanks, Michael. If anybody has questions, please ask Michael. And if there are any people who want to look at that draft and spot something that needs to be addressed or tweaked within those changes, then please let us know. It's still changeable, but we believe it's finished, and therefore it will be on the telechat agenda in December. Other than that, on to Michael to talk about the NATS support document.
Yeah, this document came back to the working group, and I submitted version 23 just because to keep it alive. There are no changes made right now. We got 2 reviews from ADs, Magnus and Martin, and there is an alternative suggestion from Claudio. So next slide. Basically, the major issues, except for wording, clarification, whatever, is are listed here. Handing off IP fragmentation at the NAT. I don't know how to address that. So controlling NAT-friendly behavior of an endpoint. So how does an endpoint know that he's behind a NAT and should behave like this? This is addressable by looking, for example, at the local addresses. Multi-homing support of internal hosts can be improved. Support of multiple external addresses should be improved. Remote addresses are not in the NAT binding table. They were removed there to make things simpler. This was it was requested that this should be put back, at least in the case where restarts are not disabled. It was a point about the complexity of packet processing at the middle box. So does the middle box need to understand chunks or not? And basically the most substantial, in my view, comment is that the current document changes the definition of an association. It takes the verification tag into account and has to deal with the case that this is not supported by the endpoints. So basically these are the major issues. And if you go to the next slide, then these are potential ways forward. One is to improve the current method which addresses issue 225. That will make things more complex. And one of the issues also was that the document is already complex. So another way to move forward would be just to use the fallback algorithm. So basically, it's like the endpoints have this understanding of this verification tag is important for the association. And if this is not possible, then the document already has a fallback mechanism. And we could just use that fallback mechanism. That would address issue 227, which is basically never disable restarts, don't use verification tags anymore, just do NAT as you would do it if you come from UDP or TCP land. It reduces complexity, it increases the chance of collisions. The third way would be switch to Claudia's draft and drop the current working document. Or the fourth solution would be just drop the work on that at all. Basically saying if we go for 2, this is very similar to UDP or TCP, so we don't need to specify it. The only way would be how do the endpoints behave. That wouldn't be specified. So these are the 4 options how to move forward, and that's what I need input on before changing the document.
So does anybody currently on this call wish to make a contribution? Do you want to comment on any of these methods or offer to review them?
So I guess the reviews are out. Magnus and Martin did a very good job in describing the issues. So the issues are clear. The question is how to address them.
Magnus.
Yes, I do think I have to think a bit more about what's the implications of these examples, but I think we should be able to. I and Claudia probably should work together and trying to see what we think jointly on these issues from our perspective, but we see that. But I will promise to think about it and come back. I would say within a few weeks.
I think that sounds an excellent outcome. Get the 3 groups of people to talk about it. Oh, Claudio, do you want to say something?
Can you hear me? Okay.
Go ahead.
Well,
Speak up. Go ahead.
I don't know. I really would like to help in this area, and this option number 3 is we talked about is more or less a subset of the current draft. It's not really a revolution. So if we could avoid dropping all the work done on that and find a solution, I am really willing to help.
Yeah, this has been the longest work item we've had, and that's not been through lack of interest, but maybe because we took on higher priority things in between. So it'd be nice to see this finished. And I don't want to go for option 4, but inevitably that will be the option we arrive at if we don't get the conclusion quite soon. Christian. Christian, you're in queue.
This reminds me of something we did in Quick for NAT traversal. And one of the problems of NAT traversal is that once you start managing NAT traversal actively, you expose yourself to a set of attacks by forged IP addresses. That is, it becomes easy to mount a man-on-the-side attack or something like that, in which someone takes an otherwise valid packet, changes the source IP address, and sends that to the other point. And that creates all kinds of state explosion issues or denial of service issues, etc. And I don't see that in the security consideration of your draft. So I I think that you should at least consider what's happening there.
Could you describe one attack scenario in particular in an email?
You want me to send you an email with the attack scenario?
With one. So who's the attacker? How does he behave, and what does he?
Yeah, I mean, I can send you an email, but the short summary is that the purpose of the attacker is to disrupt your communication. So the attacker fakes a NAT rebinding, and by faking the NAT rebinding, they convince the other point that your IP address has changed.
But the way the net binding changes is done in a specific way here.
Well, basically, you change the NAT binding to point to something where the source is, something that controls.
How can you change it?
Because NAT rebinding is something that that the other point detect by looking at incoming packets. If you change the incoming packets, you can basically drive that detection.
So the net binding is not changed dynamically.
The NAT binding has not changed at the NAT, but spoofed packet has arrived at the other points.
Can please send an email, and I'm happy to discuss this with you. I
will send you email because basically, if you want to do that, that's the reason why, for example, in Quick, when you have a NAT rebinding, you get a set of probes sent to the previous and the old address and old kind of mechanism like that.
So we verify path before we start using them, and this kind of stuff is an SCDP.
I think probably we should take this as an email thread on the list. It sounds like anything that probes into the security aspects is likely to help shed a little bit of light. Whether we need new text or not, I guess will become quite clear as we discuss it.
Okay.
Thanks, Christian. Really appreciate it. Okay, so the next person to talk will be Magnus, talking about the DTLS over SCTP document. And here's Magnus.
There. So, yes, so I'm here to talk about the details of SCTP BIS work. Yes, Ericsson has done 2 IPR disclosures related to this draft. So I want to remind you about the goal here, that the main goal here was really to ensure that DTLS can protect larger than 16,384 bytes large SCTP messages, and that this work is done on 3GPP's request. In this work, we kind of concluded on some of the RIDE requirements, especially in relation to the 3GPP use case, about long-linked SCTP associations, where we have associations that could potentially live for weeks and months. The need for, and that leads to periodic mutual re-authentication is needed. It requires rekeying with probably the Hellman key exchange to ensure forward secrecy, to reduce the impact of any key reveal, and we also need to rekey SCTP auth. Even if that algorithm is strong with SHA-256 and has a long lifetime, it's not that long, so probably. And we also want to support both DTLS 1.2 and 1.3 for having an upgrade path and ensuring that we actually can move forward with DTLS versions. So next slide. So in those issues we had and discussed last meeting and what's in the new draft, we are proposing parallel DTLS connections. And there were several issues that led us here. I mean, DTLS 1.3 lacks mutual re-authentication and has no forward secrets providing rekeying. And DTLS 1.2's renegotiation is unsecure without mutual authentication, and therefore it's often disabled, even if in this use case it would be with mutual authentication. And we also struggle with determining when keys for DTLS and SCTP auth could be retired. preferably without requiring draining at key updates. So, and that with draining, I mean getting all message flushed out, basically put the connection to idle and then rekey. So solution we propose here is to use the DTLS connection as parallel. So when you need to rekey or re-authenticate a peer, you initiate a full DTLS handshake. To enable this, we use DTLS connection IDs in all DTLS records to multiplex on. And because we're also saying we don't need me to have more than 2 alive at any point, a single byte connection ID is fully sufficient for this use case. And they can wrap, and that will be many, many hours between reusing the same connection ID representation. So, and when you're gonna switch, you have to, when all DTLS records protected by the old key has been sent and acknowledged in a non-renegable way, so you know that you've emptied out the pipeway, you know that all HTTP packets related to these HTTP messages are on the receiver side, then you go forward and close the DTLS connection that has these keys related to. And it becomes the sender's responsibility for this. And you do it in each direction individually for this indication. So when both have closed, you can remove the whole DTLS connection related state. So that's basically how it works. Next slide. So the benefits we see is they have no dependency on DTLS rekeying or re-authentication features. There's no functionality changes between supporting DTLS 1.2 or 1.3. We think this is a good property here. We currently see no limitations on the number of rekeyings you can perform, which we before had. We have mutual re-authentications and full Diffie-Hellman exchange for each time you rekey with forward secrecy, and the key reveal basically becomes limited to a single key period. So if you're rekeying every hour, the most data you leak is 1 hour, basically. And it becomes very hard to attack this because then you basically need to be able to authenticate as the peer. So, yeah. And yes. So this needs feedback. If there is one that finds any issues with the proposed solutions, so we need more eyes reviewing, the security description, etc. The target here would be to go towards working BLASTCall after review and draft updates. We are slipping a bit on the timelines here that we really thought we could hold, but that's from the struggle of finding a solution, I think. So I think that was all the slides. Yes, Martin.
Martin.
Maybe I'm confused, but if this is in fact where there are IPR issues, can you clarify what those issues are?
I mean, we have declared IPR on that. We have some IPR that we think relates to this draft. We have made licensing statements about that we will license it. Yes, I understand from, I mean, Michael's comments is that certain open source implementations might perhaps struggle with implementing this, but yeah. And the comment that, I mean, one thing I can see here, if the problem is that we replace 683, I mean, we don't need to obsolete it. We need a spec that is a solution that we can give to provide to 3DPP. So if the problem is that we obsolete the so far non-claimed, where there's no IPR claims, I mean, that's fine for us. It's from our perspective, we need a specification that solves this.
Thanks.
Thank you. I think we will have to revisit the IPR status as we progress the work, but let's take Michael Tuxen's comment as well. Michael?
Yeah, it's a bit in the direction of what Martin said. So if you want to secure HTTP traffic and limit yourself on what's been standardized by the IETF, then you have 3 solutions. One is IPsec based, one is TLS based, which is very old. I'm not aware of any deployment, and it was only done because it was needed, and there was no DTLS, and we couldn't change HTTP, we couldn't change TLS, and there's the DTLS solution. HTTP-wise, DTLS-wise, it's implemented in open source implementation, so you can use open source stacks for HTTP, for DTLS, and it works. And I'm concerned about replacing this with something which has IPRs, which we don't know yet, and I mean where we don't know yet what the IPRs cover, and so right now this can't be implemented in any open source implementation. That's what I'm concerned about, and what I'm not sure if that's the direction the working group wants to go, or I mean the goals are fine. And I think the original spec needs an update, but I'm not sure if the working group wants a version which is IPR protected.
I think I would rather take that as a real question to a future meeting when we had time to reflect on what we have and what people feel is the important way to go forward. We don't have to obsolete the current spec, and we could progress with this work as an adopted item. It already is adopted, or we could do something slightly different. But we should tackle this at a future date and finish this spec. I would encourage Magnus to continue working on it so we can see what the final spec looks like. Would that be okay, Magnus?
Yeah, yes. From my perspective, it's fine to let's continue review it, etc., and see that it works. But and as I said, we have no problem removing the obsolete 683 if that makes the working group more happy from. Because I think there's a significant difference in capabilities here, which.
Yeah, that is certainly one of the things that we should consider at the next meeting, whether we should remove that obsolete line and whether people are happy with this progress. And I'd also like you to try and talk about who might implement this spec so we can have some experience about who will review it and implement it as we get the document finished. Is that okay, Magnus?
Yes.
Cool, I thought you'd say that. That's good. In that case, any other questions, or we'll move on to the next draft? Thank you, Magnus. So the next topic, I think, on my list is UDP options. So the UDP options, what we talked about in the previous interim. Joe.
Need to go chase slides. Give me a minute here.
Yeah, that's fine. Joe attended that, and he has a slide deck that reviews some of the key outcomes of that meeting and talks about the work that remains for UDP options. So I shall present on behalf of Joe Touch. I'll make it get hard. That's great. So this is the view from Joe Touch's window. The view from my window is complete darkness. Yeah, we're in different places. I'm going to present on behalf of Joe. So next slide, if we can.
Right on here. There we go.
So the first slide here is about updates from the interim in September, at which we discussed the OCS option. Important changes that emerged were discussed as options on this mailing list previously, and finally appeared in the text of the ID. One of those is a fixed position for the OCS option. It's allocated in a place which is now visible and easily parsable. The unsafe option was changed, and really is an option that only exists behind the frag option. So This note is quite clear in the text. Please check if that was one of the concerns that you raised. And the frag option has been rewritten, rescoped, and really given a major overhaul, which started at the interim in September. More about the frag option changes in the next slides. Next slide. So the frag option is the first option after the OCS. It's given a fixed position after the fixed position of the OCS. This was largely in response to comments originally coming from Tom Herbert, which was trying to look at how easy this would be to offload in the future. So placing it in a fixed position would likely make that an easier job to solve for offload. Each fragment includes per fragment options that are placed before the data. These options relate to every datagram in every IP packet carrying a part of the datagram. That's an IP fragment. And there are things like the OCS, which are always present. There's also the possibility of having per reassembled datagram options, and they appear at the end of the reassembled datagram. In other words, in the same place as any other UDP options data. So it reassembles into the legacy format. Next slide. The idea of an MRSS was brought up at the interim and talked about there. This is a maximum value of payload that can be present in a UDP datagram. It's a number that's just chosen. It's chosen to reflect something larger than the typical MTU, and various numbers were speculated about in the interim and mailing list afterwards, and Joe finally chose the value 3000 as the default expectation that a receiver could reassemble a datagram which had a payload of 3000 bytes. It's designed to be big enough so that you can get a sizable benefit, but not too large that it claims lots of memory in the stack when it's implemented. The requirement for receivers was discussed, and the current ID has a requirement for all receivers to support reassembly of 2 fragments per UDP datagram. So a receiver that complies with the internet draft will be able to take a datagram that has been fragmented into 2 parts, reassemble those into a whole, and this will give you effectively the ability to traverse a tunnel or to send larger than 1500 bytes. The limit of 2 was added for simplicity of implementation. If you only had 2 fragments, it was argued that maybe the receiver could be less vulnerable to attacks, the code would be simpler, and probably more efficient.
Yeah, and it's also times case, which is crucial.
The actual fragment size that will be supported is a function of both the size of the underlying UDP packets you can send across the path. That's the IP packet size, and the MRSS. So if we go to the next slide, you'll see the various calculations which basically give maths to say that the amount you can expect a receiver to reassemble without any information extra than the spec would be for 2 fragments, and the 2 fragments together must be less than 3000 bytes of reassembled payload. And of course, all of this could be changed if you negotiate the MRSS option. So there's an MRSS option as well, which lets you reassemble more fragments and larger size. These slides have mainly gone through the expectation of the default behavior of a receiver that complies with the spec. So next slide, I think, just says what I said. This is a check on whether those people who were involved in this discussion, or anyone else who wants to know past comment, has opinions about this design choice of 2 fragments and the 3,000 bytes total. Otherwise, apart from this, Joe believes he's answered all the issues which were previously haunting the spec as we went through the various revisions, wanting lots of different topics to be addressed. Joe believes he's now only got consistency to address and is now willing to take more comments from the list. So that's the last slide. Comments, please.
Mike, you should go first.
I would say that there are at least 2 more issues that need to be resolved. One of them is that we don't have a mechanism spelled out in the specification for sending padding packets that are required for datagram PLM-TUD. It's not something that would require another option. It's merely a means for the upper layer protocol to be able to specify that a packet is inflated up to a certain length with zeros on the end. A second major concern that I have is per fragment options, having them at all. I think that is a very significant and unnecessary and undesirable complication on the spec, and I will take the details about this complaint to the list and leave my comments there. Thank you.
Yeah, please do. I'm not Joe. But I would like to reply on 1 per fragment option, which is the OCS, which is probably needed for traversal of a NAT.
I agree with that one.
Yeah, right. Thanks. so we should take that to the list. I've made a note of those 2 issues, and on to David, please.
I'm simply want to speak up to support the conclusion on UDP MRSS. I think 2 fragments is a good design choice because it cleanly addresses the tunnel forces fragmentation case, which is one of the things that this draft set out to solve.
Okay, thanks, David. And one of the things I was encouraging with my chair hat on was really for anybody who expects to use this, please come along and tell us, either tell the chairs or speak up on the list and say what it is you're expecting from this draft. Use cases are really good for testing whether we've got all the features we have in the right places. So the next set of slides will be presented by Tom, who's responsible for this little bit of work. Go ahead, Tom.
Nice try, Corey. You're involved too. Hi, I'm Tom Jones. This is our document that describes DPLP M2D for UDP options, or I think UDP O DPLP M2D, as we were talking about in transport earlier. It's a small document that adds the necessary features for UDP options, intended to be an example for how to write small documents like this. If you have more questions, you can ask Magnus. He asked for the document. It does a couple of very simple things. It adds to UDP options the ability to do the required features for DPLP M2D. So you can do confirmation of connectivity. We can send probes, we can validate the path, and we can do PTP handling. And it's nice and short, it's 7 pages. Since the last revision, the document was adopted. There were some temporal ordering issues between the adoption and the 0.0, because I was on holiday. And so if I have the next slide. And so that gives us the next steps. So we missed one, which was text on generating padding. So I think we still have text saying you can use NOPs. And this is forbidden by UDP options. This is fine because you can create padding by adding 0 bytes to the end of a packet. And we're actually happy with this method. We need to do an editorial pass. Gori claims there's lots of typos. So I'm waiting for a pull request, but we need to go through and be very thorough on this. We need text now to explain how DPLP-M2D works with fragments, now that fragments are starting to settle down and because we're getting happier with the design. And then we'd really like to get more comments from the working group, because it's the way to move the document. We expect this to complete alongside UDP options. And I think once we've done the first couple of things listed here, the document will mostly be in maintenance mode until UDP options is ready in the working group. And we'll just have to track what Joe changes as Joe changes things so that we stay in sync. And that's all.
So I'm willing to give up time for questions on this because it's been adopted relatively recently, and we'd like to ensure that it can also be working group last called soon, so that it coincides with the publication of UDP options. Does anybody have any questions about the presentation by Tom?
I would simply comment that the underlying mechanism here received quite a bit of review when it was part of the original DPLP MTUD. So this is not new material, and the algorithm is understood and stable.
Yeah, and this draft, although it's kind of only just become a working group item, has been around the working group and presented a number of times in the past. So there have not been major changes in between these two. It's just that we've now reached the stage of this document needing review from people. Well, when do you think we can make a new copy, Tom? In this month?
Next week. Yeah,
exactly.
I think in the next month we can have another copy. It's not a problem. There's a small amount of things to do, so it should be quite straightforward.
Okay. Does anybody wish to add any comment or questions on this before we close? Then I'll say thank you ever so much for Tom coming to speak on our joint draft. Right. Sorry for the speed at which we're going through this meeting, but it's good that we're keeping to time. And the next talk will be by Marcus on NPDCCP. So without any more introduction, would you like to update us on version 2 of your document?
Yeah, hello everyone. For sure, I'm happy to update you on the progress we made on NPDCCP. Maybe starting with some general updates. So we received a working group adoption in August this year. So quite recently, we are focusing now on maturity towards working group last call. Ideally, this is aligned with the timeline in 3GPP release 18 because there it is already discussed as part of an 80% enhancement, and the discussion is currently in the phase that they have, I think, in December to conclude if this goes for study item approval. We are also in a phase where we now start discussions with industry, with vendors to go for joint testbed and implementation activities that's going on. And we have some quite interesting discussions around that. So you keep posted on that. We are also in the phase of next open source version. We still plan to publish end of this year, aligned with the latest draft updates, and also provide much better performance. The draft development is ongoing at GitHub with currently 8 contributors. We have an established process with issue tracker and pull request used for reviews and updates. Next slide, please.
Marcus, what's the timing you need on this to align with 3GPP release 18?
I think it would be good to have maybe a working group last call then end of next year. Maybe that fits ideally. But that requires that it becomes a study item approval for sure. So that is a decision which will be made end of this year in 3GPP. Yeah, 2 weeks ago we published the first version after working group adoption. In that, we updated multiple things, though we defined a reliable exchange of multipath options for those options where it is needed. We have a consistent description of multipath reordering. So we used, or we described multipath reordering issues as part of the draft. We used different terms for describing reordering, reassembly, and so on. So they made all of this consistent. Then we added a very important section from our view on fallback strategies. So what is going to happen if multipath cannot be established? So for example, then it could be triggered a fallback to single path DCCP. We reduced the number of authors to be compliant with the RFC editor style guide, and we made some minor editorial things. If you're interested, you can look into. In the latest version we published this week, we made a lot of progress on describing a new handshaking procedure, along with authentication capabilities to guarantee a safe establishment of subsequent flows. I will come to this in the next slide. Also, some major work we did on defining or enhancing the multipath prior option for fine granular steering of path priorities, backup, and disabled path. That goes far beyond the MP prior definition from MP-TCP. Last but not least, we improved the operational section of the draft. Next slide, please. Yeah, now coming to an interesting topic which I also started to discuss on the mailing list. I shared the link in the chat now. Let me explain how we defined so far the handshaking procedure and how we improved it. So on the left, you see the initial approach we had in the draft. It's a three-way approach, we call it, because first of all, we establish the multipath connection over one link that you see from A1 to B1. It's a three-way handshake, as I indicated already. In that one, we negotiate the multipath capabilities, we negotiated key material for later subsequent flow establishment, and so on. So after the multipath connection is established, so the three-way handshake was successful, it is safe to join subsequent flows. The issue is, what you can see here, if the MP join, which is sent from A2 to B1, arrives too early at the host B and overtakes the final DCCP acknowledgement from the initial flow, then there is some confusion because the multipath connection has not been successfully established. The MP join tries to join something which is not available, and in our open source implementation, we then react with a DCCP reset on that flow, which means the subsequent flow cannot be established. That is not what we want. That's why we try to improve this in the draft as well as in the open source implementation. We are currently working now on implementing what we propose on the right side and what is already part of the draft. So we extended the three-way handshake by an additional acknowledgement we sent from the host B to the host A. With that, we know that the multipath connection has been initiated successfully, and it's safe then to start the join procedure from A2 to B1. It's a simple solution. It works. We could be happy with that. However, we wonder if this can be optimized because it adds additional delay, and also it has a high dependency that all the 4 messages of the initial flow will arrive. That's why we come to some proposals on the next slide. Starting again on the left. What we could do to optimize this, we could again go to a three-way approach as it was before. However, we do not check when we send the MP join and the MP joins arrives at host B if the multipath connection is already established. We do it at a later point with the final DCCP acknowledgement of the join process. That gives us more time, or that gives the whole establishment process more time that the initial flow is successfully established. However, that only works if there is not a too big latency difference between both paths. Otherwise, we run into the same issue as I introduced in the previous slide. That's why we also do not prefer this. However, it's a valid solution, and we are happy to discuss this with you. The preferred solution, or the optimal solution we see, is on the right, because that reduces the latency of the establishment process, or the whole time of the establishment process, and it reduces the dependency on the initial flow. So what we propose is more or less to go for a reliable two-way handshake. And what we also do in implementation is we already create all the necessary multipath structures in the network stack after the first DCCP request arrives at host B. Then we reply to this from host B to host A. We have ensured that with this or these two messages, all the key material is exchanged, which is required to derive the tokens and HMACs for a subsequent flow establishment. That means we are not reliant anymore on the final DCCP acknowledgement of the initial flow. So this one can even fail, and it has no impact because the MP join process can establish a subsequent flow and can even establish the whole multipath connection. So that is a big change in the design principle of the handshaking procedure. And we want to put the question here, if this is a good proposal, does it make sense? Or do we raise issues like providing a attack surface for denial of service attacks because we create multipath structures already in the beginning? Or do we raise security issues with that? Yeah, that is the point I would like to discuss today with you, coming with that to the last slide. So your review is very, very much appreciated, and it would really help us to move forward. So yeah, with that, I am finished for today and happy now to get your feedback.
Thank you for the update. That was very helpful. When do you think you would have more information about the options and the design considerations that you just spoke about? I'm wondering whether another meeting focused on specific points would actually be a better focus for bringing in other people into discussing this. Do you think that you might have information about that in the near term?
So it depends on what you expect. So if it is just a presentation to make a deep dive into the issues, then I think we can go quickly for that. If you expect to have those different designs implemented somewhere, then it maybe takes a longer time, or it will not be possible at all because we do not plan to implement them before we have the discussion with the IETF community.
I mean, I don't expect you to implement all the options and then come back and tell us which one was the most painful. That's clearly not the right way. So you might need to take a little bit of decision yourself about which way you think might work and see if that is actually feasible to implement. And then at that point, it might be great to bring in more people and go slowly through what you think might be the security questions and the protocol questions. And we could do that in an interim meeting, perhaps dedicated to this.
Yeah, that I would prefer and fully support to go for an interim. Maybe we can combine it with one of the other topics like STTP, but up to you what you think is best, or having a separate interim. Yeah, happy to support this, and I think we can go quickly for that.
In the meantime, we have a question from Changji.
Yes, checking here. I don't have solution or comments for your your strategy here, but what I know is currently in SA2 3GPP working group, it's talking about ATSSS for phase 3 for release 18. So it discussed the possibility to provide more than 2 passes, actually, like 2 3GPP passes or 2 non-3GPP passes. So here you are talking about only 2 passes here. So have you ever thought about like 3 or more?
Okay, that is a thank you for this question. I'm fully aware of this discussion in 3GPP, and I think it's a misunderstanding when I presented today the figures of the handshaking process that are very generic figures. That does not mean that we are limited to 2 flows. It's the opposite. So we support an unlimited number of flows.
Okay, thank you.
Thank you. Right, okay. We will talk more about this on the mailing list, and if a meeting is what's required to facilitate something, we will arrange an interim meeting for this. The next one will be Greg, who has already tried once to be on the agenda and now gets the chance for the last 5 minutes of this particular meeting. So, Greg, you have only 5 minutes. Do something useful, please, to tell us about NQB.
All right. I'll skip past the first few slides, which are just status. In fact, that one is a list of changes in draft 08 that I sent to the mailing list, so that's already been shared. I'd like to spend a little bit of time on this one. So this is the current discussion on the mailing list about NQB sender requirements and guidance on sender rates. The top paragraph in yellow describes in informative language what an NQB flow is, and it describes it as sending at most a few well-spaced packets per RTT. It gives some examples of, in today's network, no more than 1 relatively large packet every 10 milliseconds, roughly a megabit per second. The next paragraph then in green points out that just marking your packets as NQB doesn't get you off the hook in terms of implementing all of the expected features to make your application safe on the internet, including some sort of congestion control or congestion response, or circuit breaker functionalities, that sort of thing. And then the last paragraph is where it provides a specific recommendation around not marking traffic as NQB based on the sending rate. And the current text in that kind of blue-green color is if the traffic exceeds more than a few packets per RTT or exceeds approximately 1 megabit per second on an instantaneous interpacket basis, the application should not mark its traffic. And the next slide then, we can go to that. There was some discussion on the mailing list around that 1 megabit per second number in the requirement statement, and will that stand the test of time? Maybe it would be better to base that on something that that evolves over time, and the suggestion was something like 10% of the global average access link capacity at the time, and then adding an example at the time of writing what that might be, and a link to where those numbers came from. And then at the end, it does the math for you and says for a typical server application that implies no more than 6.3 megabits per second at an instantaneous rate. And for a typical client application, no more than 1.3 megabits. And here, the interpretation of a typical server is effectively a server or an application that is it's not aware whether it's sending traffic over a mobile access network or a fixed access network. And so it takes the lower of the two, but it's pretty certain it's not sending traffic in the upstream direction on an access network. It's almost certainly sending in the downstream direction. And then for the client, it takes the view that it's almost certainly sending traffic in the upstream direction on an access network. And but again, may not know whether it's mobile or fixed, so it takes the lower of the two. Questions for working group on that? Are we happy with this? With scaling the recommendation over time based on statistics that are available at the time.
We'll need to take that to the list. I'm concerned that you're using average across a distribution that's non-uniform, but this is not the place to split to dive into the statistics.
Yeah. Okay. And then moving on to the next slide, then just quickly, I think that's been discussed on the mailing list. Actually, just maybe the following slide. A question from Anna. What should these these DSCPs be labeled in the IANA registry? Should they both be called non-queue building? Maybe we should label them separately. Again, we can discuss that on the mailing list. And the last slide.
We need to fix this.
Last slide. Once these edits have been made and we've settled on those, I'm hoping we can go to working group last call, and I want to get a sense from the chairs as to if that would be advisable to try to start a working group last call in the interim before the next IETF.
I think it's worth trying to work group last call shortly after the first of the year. The other comment I'd make on this is that your light blue should text about should not use this for high bandwidth. I need to read the draft in detail. There's going to need to be some teeth behind that. Something that if a sender does that, the network is entitled to evict that flow from NQB.
Yeah. Okay. Fair enough. I can add that to the list. I see a poll has been started.
So my fault, I started the poll and then I realized you can't press the mic button when you press the poll. But at least I'd be interested in getting people to read this recent version of the spec or the current version of the spec and see how near we are. I can't really answer whether we need more time or not. Please look at it on the list and tell us your comments. Thank you, Greg. David, Wes, do we have anything else that we should say? I have one more presentation queued from Anna Kostura, and I think Anna's going to have been caught by the time. So we'll take that next meeting. Anything else from my co-chairs as we finish?
I think it's a good move here, as that needs some discussion about content. And I mean, we know something in the space is useful. Now we got to figure out exactly what.
That's fine. I place a standing offer to Anna to present more data if she has any for the next meeting, and we will try and clarify what goes in that document. Any other final comments, perhaps from Wes on session 1, if you're still there, Wes?
I don't have anything myself.
Yeah.
Excellent.
Martin, you should take note of the multipath DCCP relationship to 3GPP that will eventually surface in liaison discussions.
Yeah, roger that. Like, I mean, I think if it's not picked up as a study item, I think we need to reevaluate what we're doing. For sure.
Sure. And my final thing is I expect there to be an interim before the next meeting. So please keep a note out for that. If you have things that you think should appear on the agenda of that interim, please contact the chairs. Otherwise, we will hope to see you at the interim or in person, perhaps at the next IETF meeting. That's all for today. See you in the lobby outside if you wish to join us there in Gather.
Thank you very much, everybody.
See you all next time.